Welcome. Thanks for joining. My name is Kyle Kunz. I'm a cloud solution architect with NetApp. And today I want to talk to you about how you can monitor your Kubernetes like more of a service provider. So today, there's a lot of great tools for monitoring Kubernetes, for monitoring applications. These tools tend to not really give you visibility into the infrastructure supporting those clusters. On the other side, there's a lot of great infrastructure tools that give you great information on resource utilization, how things are performing, but they typically don't understand things like microservices or containers. So we're going to talk a little bit about the challenges with the existing tools today and the gaps for monitoring things like Kubernetes and containerized applications. We're then going to take a look at how you can monitor and manage it better with NetApp's Cloud Insights. And then we'll take a moment and show you how you can get started today. So if you're a Kubernetes owner today, you likely have a couple different tools at your disposal. Now, as an application owner, you typically care about the KPIs of your application. You likely have some sort of dedicated application monitoring tool. You've got to be the subject matter expert for getting the value out of that tool. And then you might have something for looking at your cluster, your Kubernetes configuration, your deployments, your nodes, and your pods. However, by design, as an application owner, we usually don't care a lot about the underlying infrastructure. We just ask for a certain number of resources that perform a certain way, and we expect it when we need it. Surprise. With that being said, we don't really have a way of looking at what infrastructure is supporting our cluster or our applications, which means we don't really have visibility into areas of things like resource contention or saturation. Now, on the other side of the house, we've got infrastructure tools. And if you happen to be an infrastructure owner, these are the things you look at every day. You're typically leveraging some sort of element manager to look at silos of technology. You probably also have some dedicated monitoring tools to look at business critical components of your infrastructure. And all these tools, they have a lot in common. They're going to look at traditional measurements of performance. We're going to look at things like IOPS, throughput, latency. We're going to look at the utilization of different components in that infrastructure. We're going to look for things like resource contention so we can make sure we're hitting our SLAs. However, these tools, they don't understand containers. They don't understand microservices. They don't understand things like Kubernetes. So we've got this gap in the middle for Kubernetes. How do we monitor for application-specific KPIs and our clusters to ensure we identify risk on the front end, but also get visibility through to the back end to look for resource correlation, resource contention, to plan for more resources or identify wasted resources? That brings us to Cloud Insights. So Cloud Insights for Kubernetes can help bridge this gap. So for one, very, very simple to deploy and quick time to value. We are literally talking a copy and paste of a command per cluster. You do not have to be a Kubernetes expert, an application expert, nor an infrastructure expert to start collecting data and making better decisions on Kubernetes clusters today. We also have some very quick time to value with things like out-of-the-box dashboards and visibility, as well as alerting. From the minute you start collecting data within Cloud Insights, you can identify risks on your Kubernetes clusters, on your pods, your nodes, your applications, as well as that underlying infrastructure. And last but not least, what's most important with Cloud Insights is we're going to give you one tool that provides visibility from that Kubernetes cluster all the way through to the underlying infrastructure. We can now look at things like persistent volumes, where they're coming from, what capacity we have available on the back end, and look at how this data is being mapped to our pods and our containerized applications and our persistent volume claims. So before I talk about this too much, let me just jump in and show you a live demo. So what we're looking at here is our Kubernetes Cluster Explorer within Cloud Insights. Now, the goal of this page is really just to give you some visibility into all of your clusters that you're monitoring, identify what sort of resources are being consumed by those clusters, how many nodes and pods you have running within these clusters, identifying risks, so looking for things like nodes that are not ready, pods that are pending. We can also see our top consumers as far as the number of pods map back to applications or namespaces. So we're going to jump into our indestructible cluster. Now, this is our Kubernetes Cluster Explorer. This is our Explorer wheel. This is really just here to give you an overview of this cluster. Look at the resources that are actually being consumed by the cluster. Look at your highest demand by pod for CPU, memory, and storage, and look for really any sort of alerting or risks in the environment. This wheel is designed to show you every single node in your cluster and the pods that are actually running on those nodes. As an example here, if you look at this top, you'll see a red dot. This is basically indicating we have an alert. If we come in here and click on this, you're going to notice this is a node that's hosting 18 different pods. 17 of these are healthy and one is alerting. Looking at this particular node, you're going to see every one of these pods. You're going to see the namespace they map back to or the application they're supporting. You're going to see the containers running within these pods, and you can actually even see the images running in the containers. Now, if we jump over here and look at the pod that is showing as critical, we get a lot of good information around this. We can see that the pod is not ready, even though the status is showing as running. We can see when it was created, what namespace this is part of, or what application it maps back to. We can see what kind of pod this is, IPs. Down below, we can see there's two containers running in this pod. Now, one of these is showing as running successfully, but the other shows as waiting. In this case, the error is the crash loop backoff error, which for many of us, we know likely we are unable to pull down this image from the repository we're looking at, or we're hitting some sort of like Docker rate limit. Now, all of these metrics we're looking at, these are Kubernetes metrics. They all come from kubestate metrics, and any of the tools you might be leveraging today to monitor your clusters, such as Prometheus, they're going to have these metrics available. The challenge is in the world of Kubernetes, all you have is what resources are being consumed. You don't actually have a means of measuring how they're performing. So with Cloud Insights, we can not only look at the front end cluster and all the metrics coming out of kubestate metrics, looking for resource usage, looking for risks, alerts, but we also can look at the underlying infrastructure. With Cloud Insights, we can monitor the hosts, whether that's on-prem VMs or cloud VMs. We can also monitor the storage that we're using for the persistent volumes. Let me go ahead and show you one of these clusters where we're actually monitoring that underlying infrastructure. So here we're looking at a node hosting 79 pods. You'll see all of the usual information. One difference is you'll notice this node has a virtual machine showing up here. It's a hyperlink. We go ahead and click on this virtual machine. We're going to be taken to the landing page of this VM within Cloud Insights, which now gives us our traditional metrics that we use to troubleshoot infrastructure issues and ensure we're meeting our SLAs. You'll see this VM, what a CPU utilization is, memory utilization, capacity being consumed, how it's performing. You'll see below we've got things like latency, how it's been performing over time, IOPS, throughput, CPU utilization. But just as importantly, now that we're looking at this within Cloud Insights, we can also see any sort of resource contention with things like top correlated resources and greedy or degraded resources that might be impacting this VM. What about storage? Storage is even more complex to troubleshoot. In the world of Kubernetes, all we really have is the ability to create different storage classes. But from an infrastructure perspective, we know these storage classes can sit on various types of storage, and all of those types of storage are still susceptible to resource contention, or basically other workloads that can impact our containerized applications. Now, we do monitor the storage, and we could go ahead and click through any of these clusters to see any of those persistent volume claims that map back to storage we're monitoring. But I want to show you, we don't have to always just use this out of the box overview. We also have a query engine we can leverage to go through and get answers on anything we need within our environment, whether that's the Kubernetes cluster or the infrastructure that sits beneath that. What we're going to look for today is any of our Kubernetes pods that map back to storage we are monitoring. So I'm going to go ahead and look through my Kubernetes query options, and you'll see here I've got one of these that is pod to storage. So what this is looking for is all of the pods across my cluster that have persistent volume claims mapped to storage we're monitoring today. So let's go ahead and group these accordingly. First of all, I want to group these by cluster. Then I'd like to add in the namespace. And then last but not least, I want to see the actual pods. If I go ahead and sort this, you're going to see this backend capacity. This represents storage that we're monitoring, storage where we can actually see what that capacity is of that backend volume. You can see here, we've got all these different namespaces and different pods running on our indestructible cluster. And these two specifically have backend capacity. Now I'm going to go ahead and jump into that, but let me show you. If we want to get some more details in this view, we can always add in any additional attributes. So in this case here, maybe I want to see what sort of volume is being used. I can see that internal volume name. Maybe I want to see performance attributes such as IOPS and latency associated with these particular backend volumes. Maybe I want to see things such as the phase or the PVC or the persistent volume type. We can add in any of this information we need so that at a glance we can get the answers we need on our environment. Now let me show you what this looks like here. So I'm going to go ahead and jump into this pod since I know it has some backend capacity. I can also see this capacity is doing something. We have some IO, we have some latency. But go ahead and click on this. It's essentially going to take us into the overview of this particular pod. You're going to see the information around the pod, the resource consumption. But what's new here is you can actually see the persistent volume claim. Now, let me go ahead and expand this out to show you. What we can see here is the phase of this PVC. We can see the access mode, the type. We can see the capacity used. We also have this direct link into that backend storage volume. We can see some high-level information such as the IOPS, latency, throughput, and what's actually being used on the volume versus what's being claimed from the pod. And then if I go ahead and follow this link, it's going to take us into the details that matter. Again, with Kubernetes, the only thing we can see with storage is what's being consumed and what sort of storage class we leveraged. If we need to measure the performance to understand if this is the right storage class to leverage, if we need to troubleshoot because something's not performing like it should, we need to be able to see what that underlying storage is doing. So here we can see this internal volume that we're running off of one of our NetApp arrays in our lab. We can see all the associated details with this internal volume. We can see the latency, the IOPS. We can see things like correlated resources, degraded or greedy resources that might be impacting this. But just as importantly, we can see every object that maps to this internal volume. So below we've got 164 different VMs mapped to this. But what I really want to highlight here is you can see there are two Kubernetes persistent volumes that map back to this internal volume. You can see the cluster they run on, what sort of capacity is being used, phase. If we are using storage classes, you'd see that here. You can also see the pods that are essentially mapped to this internal volume because these pods are using these persistent volumes that come off of this internal volume. So just like that, in one view, we can see everything that's mapped to this internal volume. And if I needed to go through and do any sort of capacity planning or performance troubleshooting, I can now look at all of this data. Now, these queries can be really useful for going out and getting some quick answers on your environment. And the Kubernetes Cluster Explorer, I think, can be really beneficial for highlighting risk, giving you that high-level overview of all of your clusters and who's driving resources and what resources are actually being used. But with that being said, there are likely things you care about on a regular basis, specific use cases you need to see every single morning. Depending on your role, there's things you care about and things you don't care about. So we have some out of the box dashboards that give us this visibility. Now, really just depends on what things you care about most. So as an example, if I want to see who my top consumers are, who's actually consuming the most resources within the cluster, I can come into my application showback dashboard and see who my top capacity consumers are, memory, and CPU consumers. Can see exactly what they're using, and I can dig into the details in the tables below. Now, at the same time, maybe what I care about is monitoring my applications, how they're performing, where I have risks associated with those containerized applications. So here, you're going to see some different metrics. We can see deployments with unavailable pods. We can see pods that are pending. We can see restarting containers. We can see a top-down list and how many restarts there are. We can see things like actual resource utilization, what's being used for CPU versus the requests or the limits, and how does that break down on a per namespace or application basis. We can see all of our persistent volume claims, all of our bound PVCs. Any failed PVCs will go red, so we can immediately identify if we have any sort of risk that's going to impact our containerized applications. Now, maybe we don't even care about the applications. We leave that to the actual application teams. Maybe all we care about is our cluster and where we might have some issues with our cluster that might actually impact all of the application owners. So this cluster reliability dashboard is designed to show you at a glance where you have potential issues or problems. You'll see here, across all of our clusters, we have 6 deployments without multiple replicas. So if anything happens to these deployments or these stateful sets over here, they're no longer going to exist. We do not have a replica to pick up where we left off. You'll see we have some containers here that are showing us not having a memory limit, over 2,000 containers with no memory limit. Now, this might not be an issue because we don't have any sort of issues with memory pressure, but this is a risk that we've identified. Down below, we can see node and pod runtime issues, such as 35 restarting containers. Now, this is across every single cluster. So the nice part is if you have more than one cluster, you have, say, hundreds of nodes or thousands of nodes, you can have one dashboard that highlights all of the risk you care about across everything. And if we need to, we have the ability to leverage our filters to dive into, say, a specific cluster or to look at any risk associated with a particular application or namespace. Now, with that being said, some of us don't want to log in and look at this every single day. Maybe we want to get alerted to any of these risks or issues when it happens. So within Cloud Insights, we have full stack alerting, and you could go in and configure an alert to let you know whenever any threshold is breached. So in this case here, we have quite a few different alerts that line up with those cluster reliability metrics from the previous dashboard. One of these is using CPU nanocores and essentially using too many. So you'll see here, this is an alert that goes out. We would have picked this up over email. We've got the duration of the event. We've got the node that it was triggered on. We have the cluster it's mapped back to. We have the actual condition that was breached. You'll see a timeline of the event, and this over here in red is where we actually breach those thresholds. You'll also see any related alerts here, which is critical. If we have a bunch of things happening and they're all impacting our cluster, it's important to note anything else that's happening like this in those clusters. So you'll see here in the last 3 hours, we've got a couple different alerts that are pretty much the same, where we've used more CPU than the threshold. we see the trigger time, the duration, and the fact that they're all the same. So this is happening, and it's happening fairly often. Now, if I came in here and did something about this, I also have the ability to add any comments below. That way, anyone else that logs into this alert to potentially see what's going on or to make any changes, they can see maybe someone else already acknowledged this. Maybe someone is out doing something about this. It's just a great place to keep notes so everyone on the team is aware of exactly what's happening. So what's required to get started? It's pretty straightforward. I've mentioned the copy and paste a couple of times, and this is still all that's needed to actually go out and start collecting from the clusters. But there are a couple of prerequisites. So first, I'm assuming you've got an active Cloud Insights tenant. If you don't have one of these, it's very easy to kick off a trial. Just go over to cloud.netapp.com, look at Cloud Insights where you can kick off a 30-day free trial. Next, you do need access to your Kubernetes cluster. We're going to be running some commands like curl, sudo, kubectl. So it's important you have access to that cluster. And if you do not, you have access to the cluster administrator who can help us with this. Last but not least, we do need kubestate metrics to be installed and running. Now, if you're already using something like Prometheus or other monitoring tools, odds are you have kubestate metrics running in the environment. If you don't, there's some great documentation to getting this deployed within your cluster. It's very straightforward. From there, it is a simple copy and paste. So within Cloud Insights, we're going to choose our Kubernetes data collector. We are going to choose our API token, and then we're simply going to copy this snippet and paste it right into our bash shell on the cluster we need to monitor. From there, about 15 minutes, you should start getting data within Cloud Insights, doing things like identifying risk, give you great visualizations of your clusters, and helping you map those clusters, pods, and containers to the underlying infrastructure, including the persistent volumes and any sort of compute nodes. So some key takeaways. Really, resource management on Kubernetes, regardless of how many clusters you have or how many resources they're sharing, it really doesn't have to be difficult. With Cloud Insights, you can see all this information and you can look from your storage and see how it performs and map that up to your persistent volume claims so we can better monitor the Kubernetes clusters and the containerized applications to see how that underlying infrastructure is performing. And with Cloud Insights, it's very simple to go out and detect resource contention in the environment and remediate this quickly, ensuring you're meeting your SLAs and you're offering up the resources you need to your application owners. Thank you for taking the time to watch this session. If you have any questions, please don't hesitate to reach out. Email me, give me a call. Would love to talk about Kubernetes. Thank you.